Okay, so in this example, I'm going to find the best model to represent the data. And the ones I have to deal with here, we're just going to use, it could be linear, it could be quadratic, it could be exponential, logarithmic, or logistic. So kind of just showing you all the different ones that we're going to deal with in this particular video. And we're going to use the program GeoGebra to model all of those. And again, find out the R squared value for each of those models to see which one is closest to 1. So here's some data. So what I did is I actually did this experiment. I took a cup of coffee in a styrofoam cup inside a room, and every 5 minutes I took the temperature. And so I poured the cup of coffee and I measured the temperature in Fahrenheit initially, and it was 192 degrees. Then in 5 minutes I measured it and it was 171 degrees. Then 10 minutes I measured it 155. And you can kind of see how the temperature drops clear down to 30 minutes at 121. So I'm going to take this data and see which one of all of these linear, quadratic, exponential, logarithmic, or logistic fits the best. And you know, I'm not here to teach you each one of those. I'm just here to, to show you them all. Hopefully you've had experience with all of these. A logistic might be something new to you. I would just go look it up. What is a logistic function? Go find out more about it if you don't recognize it. So here's GeoGebra. So when I open it up, this is an older version of GeoGebra, but still works great. But in this case, we just have the basic views open. So what I'm going to do is up above the screen, you won't be able to see this, but I'm going to go File and not File, but under View, I'm going to do View Spreadsheet. So look up along where your File, Edit, all that stuff is on the top of your screen when GeoGebra is open. But we're going to go ahead and View Spreadsheet. And what that does is on the side, it brings up a spreadsheet view. And I've already went ahead and put these values in GeoGebra. So there's your 0, there's your 192. And so I entered everything in already to save us some time. So I'm going to go ahead and highlight the data and do like a control click or a 2-finger click, depending on whether you have Apple or Windows machines. It doesn't really matter. And then I'm going to create a list of points. All right, and so notice the list of points appear here as a list. And we could kind of look at the whole list if we wanted to. There it is. And it also creates a list of ordered pairs, A, B, C, D, E, F, and G. And so my graph, so I'm done with my spreadsheet view. So I'm going to go back to View and click that spreadsheet view. Even though you can't see it, I apologize for that. But I'm going to click Spreadsheet again, and it'll disappear because we don't need it anymore. We've got our data on the graph that we need. And it goes all the way to 192. So I'm going to click here to Move Graphics View to kind of get this data to fit. And just pull down. And there it's starting to appear. That's fabulous. And then I'm going to pull in my time so I can get to 30. So we've got all of my data in there. So there we have it. So there's my data fit inside the window. And now I'm just going to go through that list. The first one I said was linear. So in GeoGebra, we'll go ahead and hit Fit Line. It brings up a list. So Fit Line. And it says List of Points. So we'll pull that up. And instead of List of Points, notice my list was called List 1. All lowercase, no spaces. So I'll get rid of all of that stuff that it's telling you what to put in there. And I'll just put in List 1. Get rid of any spaces that are unneeded. And hit Enter. And so there's my line. And so let's take a look at what the r squared number is for that. So I'm going to let lowercase, oh, we already have a lowercase a, so it's line. Granted, we have several, but oh, it's good. We got a, b. Let's just go b. So b is going to equal fit, or not fit, r squared. And there it is, r squared. And it says bring up a list of points, which our list is list 1. And then bring up the function we want to determine the r squared for. And our function is a. And let's see if that works. Yeah, it did. And so we have 0.96 as our r squared value for that. So the linear one has a pretty good fit, 0.96. So we'll get rid of that and bring up the next one. The next one is we want a quadratic. So let's see if it's a quadratic. Now for quadratics are x squared, which is a polynomial. And so you go fit poly, and there it is. And list of points, list 1. And the degree, quadratics are second degree polynomials. So I'll enter a 2. Hit enter. And there it is. And you can kind of see the function play out there. It looks like it also fits very nice. So we'll do a r squared. So if you remember, you might go back and look up r squared values so that you can kind of see what that means. It's a number less than 1. The closer to 1 it is, the more perfect the fit. So there's my list of points. My function in this case at quadratic is f at x. So we will put f at x. And so c is 1. Wow. So it's almost perfect for a quadratic. So we'll go options. Maybe go rounding. Maybe let's put in 15 decimals. So it's not a perfect one. It's 0.99685. So it's not perfect. B, but it is definitely better than linear. So we can get rid of the linear one. We know it's not linear, so we'll delete that one. Maybe. Oh, here. I got to be on select. There we go. So the linear one's gone, and notice it also gets rid of the r squared value. And so now let's look at the next one. So let's hide that. That's a better fit. So the next one is exponential. So we'll go fit exp, and there it is. And list of points would be list 1 again. Hit enter. And there it is. So let me show you that function. It's that g at x function. And some things to point out here with this is its rate of decay is negative 0.015. So it decays at a rate of 1.5%, in this case every minute. And 185 degrees is your 0.18. It was the initial temperature in this case when it averaged everything out. Doesn't look like it fits as well. So let's take a look here. R square, list of points, list 1, the function, g at x, hit enter, and indeed it doesn't. Which, if you know anything about Newton's law of cooling, that's the one it should be. But it doesn't fit as well for this particular data. A quadratic fits it better. But anyway, I'm just showing you this as an example of how to fit various models to data. So exponential is 0.976, not as good, but that's still not bad. And a lot of reasons could play into that. I mean, there's probably fans blowing in the room when I was doing the temperature. There's, the fact that I was touching the cup every time I take the temperature. There's a whole bunch of things that would create variations in the Newton's law of cooling. So it wasn't exactly, it was just me in a styrofoam cup. So now let's do logarithmic. So we'll go fit, let's go log, fit log, there it is. List 1, hit that, and it's undefined. So didn't work for that, and I kind of knew that to begin with, but again, I'm just kind of showing you the different ways of doing this. And then the last one's fit logistic. Oop, can't type. Fit log, and you got fit log or fit logistic. It pops up automatically. There it is, fit logistic, and list 1. Hit enter. Ooh, that's pretty. Look at that function. That is a beautiful looking function. And again, I've got 15 decimals turned on, so I mean, so it is what it is there. So let's take a look at the r squared value for it. List 1. And the function that we're taking a look at is p at x. Hit enter. And I'm going to have to hit undo because I forget which one that was. B. So I'll redo that. So B is 0.99949. Our quadratic was 0.996. Oh, so a logistic fits it better. Well, that's good. That makes me feel a little bit better about the world. And so we'll turn these all off. And you can look at the quadratic again. Boy, it's tough to see the difference between the quadratic and that logistic, but let's leave the logistic on and kind of look at our data. And there it is. And so notice it looks like it goes through almost every single point perfectly. So, and with a 0.9995, that's basically 1. So it's a beautiful fit. So I would say logistic wins out on this one. But you know, that's just a quick review of how to fit a whole bunch of different functions into a set of data and see which one works the best. And hope this helps you analyze data. You might go back and look up what r squared means so that you can understand why that 0.999 was better, and maybe go look at what a logistics function is. So that's one that's not used very often in the high school math realm, but in college here we're gonna have to take a look at that baby. So best of luck. See you next time.